Immunoprecipitation. Welcome to the show about immunoprecipitation, brought to you by Rebecca Bryant, and hosted by Rebecca Bryant, with facts from Rebecca Bryant.
Hi, I'm Alan and I'm here to talk about some important definitions for you to understand the rest of Rebecca's show. An antibody is a blood protein produced in response to a counteracting a specific antigen. An antigen is any substance that causes your immune system to produce antibodies against it. A buffer is a solution that resists changes in pH when acid or alkali is added to it. An elution is the process of extracting one material from another by washing with a solvent, as in washing of loaded ion exchange resins to remove captured ions. An assay is an investigative procedure that qualitatively assesses or quantitatively measures the presence, amount, or functional activity of a target entity. Column affinity chromatography is a bioanalytical technique which involves allowing sample, wash, and other solutions to pass through a column that is packed with porous resin onto which a target-specific antibody has been immobilized. And lastly, a Western blot is a common method to detect and analyze proteins.
So what is immunoprecipitation? Immunoprecipitation, or IP, is a technique that allows for the separation of a target protein from a complex protein mixture. It does this by precipitating a protein antigen out of solution using an antibody that specifically binds to that particular protein. Immunoprecipitation is one of the most widely used methods for isolation of proteins and other biomolecules from cells or tissue lysates for the purpose of detection by Western blotting or other assay techniques. It was first developed by, we do not know who developed this technique, because that was apparently lost in translation. I also searched everywhere and found nothing. But it was developed as an adaptation to column affinity chromatography. So it is an A1 genius technique. So let us thank all of the scientists out there. Anyways, moving on. Instead of using a packed column, like in column affinity chromatography, IP uses a small amount of resin and a microcentrifuge tube, and then incubation steps are performed using several batches. For each step, a solution is added to the beads, which are then mixed and incubated together. At the end of each incubation step, the beads are pelleted to the bottom of the tube by centrifugation or by a magnet, so that the solution can be removed using a pipette. Remember, the goal of IP is to isolate just enough protein to be able to measure it by Western blotting or another quantitative assay method. Further on, here's the basic protocol for IP. IP steps can be done in two different ways, but each step involves incubation, followed by a bead collection and the removal of the solution. Wash steps are also included after each incubation step. And the elution during the final step typically involves heating the beads in a sample loading buffer for an SDS page, which results in denaturation of the proteins, including the antibody, and then irreparable damage to the beads, which will be discarded afterwards. In one sequence, which is seen on the left, an antibody against a specific protein is pre-immobilized onto an insoluble support, such as agarose or magnetic beads, and then it begins the incubation phase with a cell lysate containing the target protein. And during that incubation period, there is a gentle agitation to the lysate that allows the target antigen to bind to the immobilized antibody. The immobilized immune complexes are then collected from that lysate and then eluted from the support and analyzed based on the nature of the target antigen. Alternatively, as you can see on the right, free unbound antibody is allowed to form immune complexes in the lysate, and then complexes are then retrieved by the beads. While the pre-immobilized antibody approach is more commonly used for IP, using a free antibody to form these immune complexes is definitely beneficial if the target protein is present in low concentrations, because the antibody has a weak binding affinity for the antigen, or the binding kinetics of the antibody to the antigen will be slow. Alright, so once you're done with your immunoprecipitation technique, you can put your protein in a Western blot or another assay to analyze it. Looking for ways to improve your Western blots? Well, look no further, because we have the solution. Come on down to Ace's Beads. Try out our new products for your next immunoprecipitation. Guaranteed to make your protein analyses way better than they ever were before. These products are good for every type of IP out there. If you need it, we've got it.
Right, Sally. Right.
We are not liable for damage to your protein.
Back to the show. Back.
There are pros and cons to immunoprecipitation. Some pros include that it's fairly cheap and easy to do, and it's a much faster technique than column affinity chromatography. Now, some cons include that it has to be paired with another protein analysis technique, and the process won't work if the protein does not bind to the antibody. So, what did we learn today? We learned that immunoprecipitation is a better form of column affinity chromatography. This technique is used to isolate and concentrate a specific protein from a much more complex protein by precipitating a protein antigen out with an antibody. So just remember, IP is the way to go.
Thank you for watching. Thank you.